All right. Definition. A relation means a relationship between two variables. So a relationship between two variables. So you have two things that are going on and there's a relationship between them. We have done this before. Do you remember the one on the study guide or the test where you had like an actual train and then a model train, and we did a relationship between the feet of the real train and the centimeters of the model one? Or do you remember when we had the map and like real life compared to like the centimeters on the map? Is this making sense to you? Relationship between like the large object and the small object? It's that, okay? It's exactly what it is. So there are a bunch of different ways that you can view these, that they can be represented, and all we're covering today is these different representations, okay? So a relation can be represented by ordered pairs, or in other words, points, ordered pairs, something comma something else. I'm just going to make up a little example for us to use to show these four ways that this can be represented. So just bear with me. I'm just going to write out some points. For example, -1, 3. It's something comma something else. It's just an ordered pair. And I'm just going to list out a few of them so that we have like a list. We'll do 4, 2, 4, -3, and -2, -3. You have an input and you have an output, or x, y. Does that ring any bells from last year? Like something comma something else? Okay. It's just ordered pairs. That's all that they are. It's a relationship between the x and the y. So you can write them just as a list of points like that. Or you can make a table, which is going to look a lot the same, except in table format. So if you draw yourself a table, x, y, and I'm just going to use the exact same numbers for all of these examples just to be consistent. So if you take this -1, 3, you would just write it on your table like that. If you're like, that's it? Yeah, that's literally it. And then same thing with 4, 2. And then 4, -3. And -2, -3. Now, technically, the x numbers should go in order, smallest to biggest, but I would never mark that wrong because, for goodness sake, if you get them all, I'm thrilled. Okay. So, like, technically, these should be like in order, smallest to biggest, but it's fine the way it is. Have you seen a table before? Is this familiar? Yes. Okay. You have to let me know if you've seen this one. A mapping. I kind of like drawing these ones. So what you're going to do is draw a big oval. This is going to be for all of the x's, and then draw another one that's going to be for all of the y's. So you have input and output. So we're going to represent these ordered pairs in a mapping. So watch, it's -1, 3. I'm going to put -1 with the x's, 3 with the y's, and you just draw an arrow to show that it maps from -1 to 3. It's like drawing a little picture. And then we're going to do the same thing with 4, 2. I'm just going to write 4 here and 2 here and draw a little arrow. Miranda, are you writing this down with me? Oh, okay. Now 4 to -3. Do not write the 4 again because you already have a 4 there. All you need to do is put the -3 over there and just draw another arrow to it. Will I take off if you write it a second time? Yeah, because technically you're not supposed to do that. Okay. So if you have a repeat, you don't write it twice. You just have one of them. And then the last one, -2 to -3. So I wrote the -2. I'm not going to write another -3 though, because do you see how I already have one? And then just draw that arrow in there. So just make sure you don't repeat them. You're not supposed to do that. And then the last way you can represent this is with a graph. So what you're going to do is draw your coordinate plane. And I think you should label your x and y axis. This way is x, this way is y. Just label it every time so you don't mix it up. And then we're going to just plot these 4 points. So draw yourself like some tick marks. I picked small numbers so you won't have to go very far. Have you plotted points before too? Did you do that in Math 8? Okay. Let's review the quadrants real quick because you do have to know that. Where is quadrant 1? And I'm looking for the top right. Good. This is quadrant 1. Do you remember this?
Yeah, it's 2 on the bottom.
2 is.
Oh, no, not 2.
2 is this one. 3 is down here, and then this one is 4. So 1, 2, 3. It goes like counterclockwise. You do have to know that. That would be like a question on your quiz, like what quadrant is the point in? So you do have to know that. But we're just going to plot these. So -1, 3. You're going to go -1 on the x-axis. Just watch me point to this because this is really easy to do, but also really easy to do backwards. So just be careful. You go -1 on the x-axis and then 3 on the y-axis. It would be in quadrant 2. So there's our point. What quadrant would 4, 2 be in? 1. Good. You would go 4 on the x-axis, 2 on the y-axis. So 4, 2. I think I put 1 in each quadrant. What quadrant would 4, -3 be in? You would go 4 for x, -3 for y. 4, good. You would go 4 on x and then kind of like down 3, -3 for y. So that's going to be right here. And then -2, -3 would be in the third quadrant. You go -2 on the x-axis, -3 on the y-axis. Do you connect those? No, it's just 4 random points that we plotted, just like a constellation. So those are the 4 ways you can represent relations, okay? Just a connection, a relationship between the 2 variables. So vocabulary, for the x coordinate, we can say input. That's what you input to the function. It is the independent variable. So your input is your independent variable. And then the other word we associate with that is domain. Have you done domain? And do you remember what the word is for the y? Oh, good. Okay, so you have heard of that. Domain is just all the inputs. Range is just all the out. I was hoping that this lesson would be like a really simple, quick one, like you've seen this. So if we take all that and relate it to the y coordinate, instead of input, it would be output. Like you input x, you get back y. And it would be the dependent variable. So y depends on x. So whatever you get for y, it depends on whatever x was in the first place, like what you plugged in. And then yes, it would be range. So you have domain for all the inputs, range for all the outputs. You hanging in there? We're all good, we're all on board. Okay. I know it's not super exciting, but you have to know it to pass high school, okay? So now we're going to do an example. Express this relation. So I gave all these ordered pairs as a table, a mapping, and a graph. Okay, so let's draw a table. So x, y. And you are really just going to copy all of those points. It's almost like no work. You just have to copy. Just don't do a copy error. So we've got 3, 2, -1, 4, 0, -3. I'm going to stop reading them because I know that's annoying. Just basically copy them all down. It's only 5 points. You can do it. I'll give you a pep talk. Go team. And then for the mapping, just pick up where we are. I'll give you this one at the early. I said I was going to give you this one, but it looks like you're writing it all. Don't hurt your hand. Okay. Okay. So for the mapping, it's like drawing a little picture. You draw yourself these 2 like ovals. This one's for x, this one's for y. The only thing is don't repeat any of them. Like if the number's already there, don't write another one. So we've got 3, 2. So you're connecting those together. I like drawing the mappings. It's like a little picture. So 3, 2, -1, 4. So just check if that number's already there before you write it, because you just don't want to repeat any. So 0, -3. Actually, not sure any of these do repeat. Oh, wait, here we get one. -3, 4. So I have to write the -3, but do you see how there's already a 4 over here? Yeah, so just your arrow will cross over the other ones. If that bothers you, I'm sorry. That's okay when that happens though. So -3 goes to 4. And then -2 to -2. I like the mapping. I think that's my favorite one. You like the graph? And then all you're going to do is plot those. So 3, 2. This is going to be a little easier than the other one because we have a grid this time. So 3, 2. I'm just going to check, you know, the quadrants. -1, 4. What quadrant would that be in? Quadrant 2. Good. -1, 4. Be right here. Oh, let's talk about this one. 0, -3. That would be right here. What quadrant is that in? Well, it's not in a quadrant, it's on an axis. So instead of stating a quadrant, you would state the axis it's on. So which axis is that on, X or Y? You would say Y axis if it lands on it. All right, -3, 4 would be up here in quadrant 2. So this one right here. And then where is -2, -2? Yes, ma'am. Over here? Hold on. Oh, I'm sorry. You're correct. Thank you. So we got to look after each other. 3, 2. I put it at 3, 1. I'm sorry. Did I get all the other ones right? Or did I mess up on these? -1, 4, 0, -3. -3, 4. Okay, good. And then what quadrant is -2 going to be in? 3. Good. Perfect. Right here. Don't connect them. I get some people that'll connect them sometimes. Don't do that. It's just like a constellation. You just leave them all be. Okay, cool. This is going well. Express the relation in the table as all the other things. This time I gave you the table instead. We're going to write it as the ordered pairs, the mapping, and the graph. Do you want me, let me be quiet and let you guys try this one, and then I'll give you the answers. I'm going to hit pause on the recording. All right, I'm going to write down the ordered pairs so that you can start checking your work. You're just linking them together. So -3, 5, -1, -4, and then so on. I'm not going to read them all because I know that can be a little bit annoying. Just please look at them and make sure yours is right. You're going to be sad if you miss one of these questions because it's really just recopying the information that's there. So please just make sure you can do it. So that's all that there is for that. For the mapping, just make sure you don't repeat any of them. So if there's already the number there, you just use what's already there. So -3 goes to 5. -1 goes to -4. 1 goes to 4. And then for the next one, 1, 0, you're not going to repeat this 1. You just need to put the 0 on there and draw in another arrow. All right, so let's see. 4 goes to 3. I may need to extend my bubbles here. Yeah, I do. So 5 goes to 5. And then 6 goes to negative. Gosh, I can't repeat any of those. I know, I see. I could have sworn that there was one that repeated. Too many numbers in here. Sorry. 5 goes to 5. There we go. It crosses all over all of those. And then 6 goes to -3. Let me make that look a little bit prettier. I thought there was another one. Another 5 in there. So my arrows kind of crossed over each other. That's okay. Let me just make sure I'm good here. 1 goes to 0, 4 goes to 3, 5 goes to 5. We already had a 5 in there, and then 6 goes to -3. All right, cool. Then we're going to plot them. X and Y axis, it's already labeled, but it's really tiny, so I'll just write it a little bit bigger. So -3, 5, what quadrant is that going to be in? 1, 2, 3, or 4? Second, good. -3, 5. Be right there. -1, -4. So they're both negative. It's going to be in the third quadrant. 1, 4 will be right here, first quadrant. 1, 0. Which axis is that going to be on? The X axis or the Y axis? 1, 0. X, good. It'll be right here. Do you know that that's also called an intercept? Have you heard that word before? Okay, just checking. All right, 4, 3 will be right here. 5, 5, also in the first quadrant, and then 6, -3 is in which quadrant? Fourth. Okay, perfect. All right, and then we're gonna end with a word problem. So movie tickets cost $12 per person, independent and dependent. Okay, listen to which one of these sentences makes more sense. Money depends on the people, or the number of people depends on how much money.
The first one.
Let me say them again. How much money you spend depends on how many people go, or how many people go depends on how much money you spend.
The first one.
Money depends on how many people go. How much money you end up spending depends on how many people go. Put the phone away. Or the number of people depends on how much money you have already spent. Which one is independent? People. How much money you end up spending at the movie theater is going to depend on how many people go. Do you get that? Money depends on people. I get what you're saying about the other way around though. Like how many people are allowed to go depends on like how much allowance you have. That's kind of not what this is asking though. It's like, how much do you spend? Well, it depends on how many people go. So we're going to make a table. So make a table X and Y to show the relationship between the two variables for groups of 4, 7, 11, and 15 people. So we're going to put 4, 7, 11, and 15 on our table. So if 4 people go to the movies, how much money do you spend? Well, how could you figure that out? Yeah, multiply by like the $12, right? If you have 4 people that go and it's $12 per ticket, we're not including like popcorn and whatever. 4 times 12, $48. And then same for 7, you're just gonna multiply it by the $12. So that would be, oh, close. 84. I'll bring up the calculator for us now because it's here. Where's my calculator? There it is. All right, so 12 times 11, or does anyone know that one? 132. Close. You know, estimating is a good like skill to have. And then 12 times 15. So if you take 15 people to the movies, it's going to be $180. Adds up quick. I remember when movies were like $2. Those are the cheap theaters though. The more expensive ones were like 7 or 8. All right, and then graph the relation. We're going to label the X and Y axes. So what's going to go down here? What was our independent variable? Look back. What was independent? People. And money depends on people. How much you spend depends on how many people go. So this side would be money. Dollars, cash money. And then we're just going to plot those points. We're going to graph this relation. So 448. Now it's not going to be perfect, but 48 would be like, you know, just under 50. When in doubt, just make the dot larger. Do you know what I'm saying? And then it'll just take up more space. All right, 784. So like, as long as it's somewhere between 80 and 90, you're good. All right, and then 11, 132. And 15, 180. Oh, that one's actually exactly on a nice spot. Okay, I want you to understand something. We're not connecting them, but if we did, if I connected these, what kind of a shape am I getting?
A line.
A line. Why is it going up?
Because the number of money increases.
Yeah, money, the more people you take, the more money it's going to cost to go to the movie theater. And if you take 0 people, it would cost $0. So like you'd start there. Cool.